For hundreds of great shows like this one, go to OnNetworks.com.
Hi, I'm Dr. Kiki Sanford, and today on Food Science, things are getting a little hot and spicy. Of all the spices in the kitchen, the ones that make the least sense are those that cause pain. Why do I love you so much? Plants create all sorts of compounds to protect themselves and their fruits from being eaten by insects and animals. In high enough concentrations, they can even be toxic, but when little bits are used in cooking, they provide a pleasing aroma or flavor. Pungent or piquant chemicals, on the other hand, reliably cause pain, or at least irritation, and even reduce our ability to taste by distracting our brain away from taste sensations. It's thought that plants evolved painful chemicals to keep their fruits and seeds from being eaten and destroyed by the grinding of mammalian teeth. This must have been a master plan devised by the plants to get their seeds sown successfully. But somewhere along the way, their plan backfired because us humans developed a taste for pain. So it's chemicals that make hot stuff hot. But different plants produce different chemicals, which result in unique perceptions of hot or pain. There are two groups of pungent plants. One that creates chemicals called isothiocyanates, which are found in mustard plants, horseradish, and wasabi. The other group creates compounds called alkyl amides and includes chili peppers, black peppers, and ginger. Although the chemicals created by the plants are different, they all seem to act in a very similar manner. They bind to and stimulate temperature receptors within the nasal cavity and digestive tract. Normally, the receptors respond to a physically hot stimulus by sending the message to the brain so that the body can react appropriately. But in this situation, they're being chemically activated. The result is the sensation of irritation or pain and the perception of heat, but no actual damage occurs. Did you know that the chemicals in Sichuan peppers act on many different nerve endings, resulting in a strange combination of numbness, tingling, and irritation? The location of chemical action seems to be the crucial difference in how the various chemicals are perceived. The isothiocyanates are small molecules that become volatile fairly readily, which means that they end up in the air in our mouths and sinuses as we chew. They float into the sinuses where they make contact with nerve endings leading to the brain. This explains why Russian mustards and wasabi always make my head and sinuses burn, but never my mouth or tongue. The alkyl amides are bigger, which means that they pretty much stay in your mouth, at least until they end up in the rest of your digestive tract. That's why salsas and curries make your mouth so hot. The compound found in chili peppers is called capsaicin, after the species name of the plant, capsicum. Black pepper contains piperine. Sichuan peppers contain sanshool. Piperine and sanshool are less pungent than capsaicin, which explains why black pepper doesn't pack as big a punch as a habanero. Capsaicin is contained in the seed-bearing tissue of chili peppers, which is called the placenta. But for all the hot spices, concentration is key. The more spice you add to a food, the hotter it will be because more receptors will be activated, leading to a more extreme sensation. You want to take a bite? Your body senses heat, so cooling mechanisms like sweating and vascular dilation are turned on. In addition, because it is a noxious stimulus, your body's fight or flight system gets activated. Your metabolism revs up to provide you with plenty of energy. Heart rate and blood flow to your muscles and brain increase. You feel more alert. Endorphins are released to quell the pain, and your appetite gets turned down so that your escape won't be hampered by hunger pangs. Phew, what a ride! No wonder we love the burn so much. It leaves a person feeling great, invigorated even. But if you do bite off more than you can handle, try using some ice to cool your mouth down. It will chill the receptors so that they stop sending their messages to the brain. Alternatively, capsaicin and the others are oil-soluble, so try drinking a glass of milk or mango lassi even instead of reaching for a glass of soda or water. But remember, it's not just food, it's science.
For hundreds of great shows like this one, go to OnNetworks.com.